Nickel is a chemical element with symbol Ni and atomic number 28. It is a silvery-white lustrous metal with a slight golden tinge. Nickel belongs to the transition metals and is hard and ductile. Pure nickel shows a significant chemical activity that can be observed when nickel is powdered to maximize the exposed surface area on which reactions can occur. But larger pieces of the metal are slow to react with air at ambient conditions due to the formation of a protective oxide surface. Even then, nickel is reactive enough with oxygen that native nickel is rarely found on Earth's surface, being mostly confined to the interiors of larger nickel-iron meteorites that were protected from oxidation during their time in space. On Earth, such native nickel is found in combination with iron, a reflection of those elements' origin as major end products of supernova nucleosynthesis. An iron-nickel mixture is thought to compose Earth's inner core. The use of nickel has been traced as far back as 3500 BCE. The element's name comes from a mischievous sprite of German minor mythology, Nickel, that personified the fact that copper-nickel ores resisted refinement into copper. An economically important source of nickel is the iron ore limonite, which often contains 1 to 2% nickel. Nickel's other important ore minerals include garnierite and pentlandite. Major production sites include the Sudbury region in Canada, New Caledonia in the Pacific, and Norilsk in Russia. Because of nickel's slow rate of oxidation at room temperature, it is considered corrosion-resistant. Historically, this has led to its use for plating metals such as iron and brass, coating chemistry equipment, and manufacturing certain alloys that retain a high silvery polish, such as German silver. About 6% of world nickel production is still used for corrosion-resistant pure nickel plating. Nickel-plated items are noted for provoking nickel allergy. Nickel has been widely used in coins, though its rising price has led to some replacement with cheaper metals in recent years. Nickel is one of 4 elements that are ferromagnetic around room temperature. Alnico permanent magnets based partly on nickel are of intermediate strength between iron-based permanent magnets and rare earth magnets. The metal is chiefly valuable in the modern world for the alloys it forms. About 60% of world production is used in nickel steels. Other common alloys, as well as some new superalloys, make up most of the remainder of world nickel use, with chemical uses for nickel compounds consuming less than 3% of production. As a compound, nickel has a number of niche chemical manufacturing uses, such as a catalyst for hydrogenation. Enzymes of some microorganisms and plants contain nickel as an active site, which makes the metal an essential nutrient for them. Properties. Atomic and physical properties. Nickel is a silvery-white metal with a slight golden tinge that takes a high polish. It is one of only 4 elements that are magnetic at or near room temperature, the others being iron, cobalt and gadolinium. Its Curie temperature is 355 degrees Celsius, meaning that bulk nickel is non-magnetic above this temperature. The unit cell of nickel is a face-centered cube with the lattice parameter of 0.352 nanometers, giving an atomic radius of 0.124 nanometers. This crystal structure is stable to pressures of at least 70 gigapascals. Nickel belongs to the transition metals and is hard and ductile. Electron configuration dispute. The nickel atom has 2 electron configurations, R3d84s2 and R3d94s1, which are very close in energy. The symbol R refers to the argon-like core structure. There is some disagreement as to which should be considered the lowest energy configuration. Chemistry textbooks quote the electron configuration of nickel as R4s23d8, or equivalently as R3d84s2. This configuration agrees with the Madelung energy ordering rule, which predicts that 4s is filled before 3d. It is supported by the experimental fact that the lowest energy state of the nickel atom is a 3d84s2 energy level, specifically the 3d84s23f. J equals 4 level. However, each of these configurations in fact gives rise to a set of states of different energies. The two sets of energies overlap, and the average energy of states having configuration R3D94S1 is in fact lower than the average energy of states having configuration R3D84S2. For this reason, the research literature on atomic calculations quotes the ground state configuration of nickel as R3D94S1. Isotopes. Naturally occurring nickel is composed of 5 stable isotopes: 58 Ni, 60 Ni, 61 Ni, 62 Ni and 64 Ni, with 58 Ni being the most abundant. 62 Ni has the highest nuclear binding energy of any nuclide. Its binding energy is greater than both 56 Fe, often incorrectly cited as the largest, and 58 Fe. 18 radioisotopes have been characterized, with the most stable being 59 Ni with a half-life of 76,000 years, 63 Ni with a half-life of 100.1 years, and 56 Ni with a half-life of 6.077 days. All of the remaining radioactive isotopes have half-lives that are less than 60 hours, and the majority of these have half-lives that are less than 30 seconds. This element also has one metastate. Nickel-56 is produced by the silicon burning process and later set free in large quantities during type Iowa supernovae. The shape of the light curve of these supernovae at intermediate to late times corresponds to the decay via electron capture of nickel-56 to cobalt-56 and ultimately to iron-56. Nickel-59 is a long-lived cosmogenic radionuclide with a half-life of 76,000 years. 59 Ni has found many applications in isotope geology. 59 Ni has been used to date the terrestrial age of meteorites and to determine abundances of extraterrestrial dust in ice and sediment. Nickel-60 is the daughter product of the extinct radionuclide 60 Fe, which decays with a half-life of 2.6 million years. Because 60 Fe has such a long half-life, its persistence in materials in the solar system at high enough concentrations may have generated observable variations in the isotopic composition of 60 Ni. Therefore, the abundance of 60 Ni present in extraterrestrial material may provide insight into the origin of the solar system and its early history. Nickel-62 has the highest binding energy per nucleon of any isotope for any element. Isotopes heavier than 62 Ni cannot be formed by nuclear fusion without losing energy. 48 Ni, discovered in 1999, is the most proton-rich heavy element isotope known. With 28 protons and 20 neutrons, 48 Ni is double magic, and therefore unusually stable. The isotopes of nickel range in atomic weight from 48U to 78U. Nickel-78's half-life was recently measured at 110 milliseconds, and is believed an important isotope in supernova nucleosynthesis of elements heavier than iron. Occurrence on Earth. Nickel occurs most often in combination with sulfur and iron in pentlandite, with sulfur in millerite, with arsenic in the mineral nickeline, and with arsenic and sulfur in nickel galena. Nickel is commonly found in iron meteorites as the alloys carmesite and tannite. The bulk of the nickel mined comes from two types of ore deposits. The first are laterites, where the principal ore minerals are nickeliferous limonite, and garnierite, 3C2054. The second are magmatic sulfide deposits, where the principal ore mineral is pentlandite, 9S8. Australia and New Caledonia have the biggest estimate reserves. In terms of world resources, identified land-based resources averaging 1% nickel or greater contain at least 130 million tons of nickel. About 60% is in laterites and 40% is in sulfide deposits. Based on geophysical evidence, most of the nickel on Earth is postulated to be concentrated in the Earth's outer and inner cores. Carmesite and tannite are naturally occurring alloys of iron and nickel. For carmesite, the alloy is usually in the proportion of 90 to 10 to 95 to 5, although impurities may be present. While for tannite the nickel content is between 20% and 65%. Carmesite and tannite occur in nickel-iron meteorites. Compounds. See also. Category: nickel compounds. The most common oxidation state of nickel is +2, but compounds of Ni0, Ni+, and Ni3+ are well known, as well as exotic oxidation states Ni2-, Ni1-, and Ni4+. Nickel tetracarbonyl 4, discovered by Ludwig Mond, is a volatile, highly toxic liquid at room temperature. On heating, the complex decomposes back to nickel and carbon monoxide. Ni4 Ni+4CO. This behavior is exploited in the Mond process for purifying nickel, as described above. The related nickel complex bis-nickel is a useful catalyst in organonickel chemistry due to the easily displaced COD ligands. Nickel-nickel complexes are uncommon, however one example is the tetrahedral complex NiBr3. Many nickel complexes feature Ni-Ni bonding, such as the dark red diamagnetic K4, Ni26, prepared by reduction of K2, Ni26, with sodium amalgam. This compound is oxidized in water, liberating H2. It is thought that the nickel oxidation state is important to nickel-containing enzymes, such as NIF hydrogenase, which catalyzes the reversible reduction of protons to H2. Nickel forms compounds with all common anions, i.e., the sulfide, sulfate, carbonate, hydroxide, carboxylates, and halides. Nickel sulfate is produced in large quantities by dissolving nickel metal or oxides in sulfuric acid. It exists as both a hexa and heptahydrates. This compound is useful for electroplating nickel. Common salts of nickel, such as the chloride, nitrate, and sulfate, dissolve in water to give green solutions containing the metal aquo complex, Ni6, 2+. The four halides form nickel compounds. The structures of these solids feature octahedral Ni centers. Nickel chloride is most common, and its behavior is illustrative of the other halides. Nickel chloride is produced by dissolving nickel or its oxide in hydrochloric acid. It is usually encountered as the green hexahydrate, the formula of which is usually written NiCl26H2O. When dissolved in water, this salt forms the metal aquo complex, Ni6, 2+. Dehydration of NiCl26H2O gives the yellow anhydrous NiCl2. Some tetracoordinate nickel complexes, e.g., bis-nickel chloride, exist both in tetrahedral and square planar geometries. The tetrahedral complexes are paramagnetic whereas the square planar complexes are diamagnetic. This equilibrium as well as the formation of octahedral complexes contrasts with the behavior of the divalent complexes of the heavier group 10 metals, palladium and platinum, which tend to adopt only square planar geometry. Nickelocene is known. It has an electron count of 20, making it relatively unstable. Nickel and numerous Ni compounds are known, with the first such examples being nickel trihalophosphines X3. Further, Ni forms simple salts with fluoride or oxide ions. Ni can be stabilized by sigma donor ligands such as thiols and phosphines. Ni is present in the mixed oxide BaNiO3, while Ni is present in nickel oxide, which is used as the cathode in many rechargeable batteries, including nickel cadmium, nickel iron, nickel hydrogen, and nickel metal hydride, and used by certain manufacturers in Li-ion batteries. Ni remains a rare oxidation state of nickel and very few compounds are known to date. History. Because the ores of nickel are easily mistaken for ores of silver, understanding of this metal and its use dates to relatively recent times. However, the unintentional use of nickel is ancient, and can be traced back as far as 3500 BCE. Bronzes from what is now Syria have been found to contain up to 2% nickel. Further, there are Chinese manuscripts suggesting that white copper was used there between 1700 and 1400 BCE. This Paktong white copper was exported to Britain as early as the 17th century, but the nickel content of this alloy was not discovered until 1822. In medieval Germany, a red mineral was found in the Erzgebirge that resembled copper ore. However, when miners were unable to extract any copper from it, they blamed a mischievous sprite of German mythology, nickel, for besetting the copper. They called this ore Kupfer-nickel from the German Kupfer for copper. This ore is now known to be nickeline, a nickel arsenide. In 1751, Baron Axel Friedrich Kronstedt was trying to extract copper from Kupfer-nickel at a cobalt mine in the Swedish village of Los, and instead produced a white metal that he named after the spirit that had given its name to the mineral, nickel. In modern German, Kupfer-nickel or Kupfer-nickel designates the alloy Kupfer-nickel. After its discovery, the only source for nickel was the rare Kupfer-nickel, but from 1824 on, nickel was obtained as a byproduct of cobalt blue production. The first large-scale producer of nickel was Norway, which exploited nickel-rich pyrrhotite from 1848 on. The introduction of nickel in steel production in 1889 increased the demand for nickel, and the nickel deposits of New Caledonia, which were discovered in 1865, provided most of the world's supply between 1875 and 1915. The discovery of the large deposits in the Sudbury Basin, Canada, in 1883, in Norilsk-Talnak, Russia, in 1920, and in the Merensky Reef, South Africa, in 1924 made large-scale production of nickel possible. Nickel has been a component of coins since the mid-19th century. However, in Birmingham there were already Dutch silver 18th-century coins forged in nickel around 1833. In the United States, the term nickel, or nick, originally applied to the copper-nickel Flying Eagle cent, which replaced copper with 12% nickel 1857 to 58, then the Indian head cent of the same alloy from 1859 to 1864. Still later, in 1865, the term designated the 3-cent nickel, with nickel increased to 25%. In 1866, the 5-cent shield nickel appropriated the designation. Along with the alloy proportion, this term has been used to the present in the United States. Coins of nearly pure nickel were first used in 1881 in Switzerland, and more notably, 99.9% nickel 5-cent coins were struck in Canada during non-war years from 1922 to 1981, and the metal content made these coins magnetic. During the wartime period 1942 to 45, most or all nickel was removed from Canadian and U.S. coins, due to nickel's war-critical use in armor. Canada used 99.9% nickel from 1968 in its higher-value coins until 2000. In the 21st century, the high price of nickel has led to some replacement of the metal in coins around the world. Coins still made with nickel alloys include 1 and 2 euro coins, 5, 10, 25 and 50 US coins, and 20p, 50p, £1 and £2 UK coins. The replacement of nickel alloy 5p and 10p UK coins with nickel-plated steel models, begun in 2012, has caused dermatological controversy. World production. The Philippines, Indonesia, Russia, Canada and Australia are the world's largest producers of nickel, as reported by the U.S. Geological Survey. The largest deposits of nickel in non-Russian Europe are located in Finland and Greece. Identified land-based resources averaging 1% nickel or greater contain at least 130 million tons of nickel. About 60% is in laterites and 40% is in sulfide deposits. In addition, extensive deep-sea resources of nickel are in manganese crusts and nodules covering large areas of the ocean floor, particularly in the Pacific Ocean. The one locality in the United States where nickel was commercially mined is Riddle, Oregon, where several square miles of nickel-bearing garnierite surface deposits are located. The mine closed in 1987. The Eagle Mine project is a new nickel mine in Michigan's Upper Peninsula. Completed in 2013, it began operations in the third quarter of 2014. In its first full year of operation, Eagle Mine produced 18,000 tons